really powerful device, and that's how we see OcuWell. Good, well, now we are on to Pixel-Flo, so the final company of the day, and we'll turn over to Rick and we'll use these healthy eyes to look at new displays.
Thanks, Miles. Thanks. I'm Rick Smith, CEO and co-founder of Pixel-Flo. So Pixel-Flo's groundbreaking manufacturing technology will enable the next generation of micro-LED display products in this $160 billion display industry, finally making micro-LED displays commercially viable. We're surrounded by increasing numbers of displays. You can see quite a lot now. Most of you are probably carrying 2 or 3 display products, several hundred displays just in this room. The display industry moves quickly to adopt new technologies to offer better products and have invested billions so far in the micro-LED supply chain. So why are these manufacturers racing to adopt micro-LED display? Because micro-LED displays are significantly brighter, more efficient, and more durable than OLED and LCD technologies. And these are not small changes, these are step changes. So in terms of efficiency, for example, a micro-LED TV can be up to 90%, use up to 90% less energy than LCD, with significant battery life implications. This is enabled by making displays out of millions of microscopic inorganic LEDs, the most efficient way of making light. And to Stan's point on venture scale earlier on, this is a huge venture scale opportunity. Adoption in a single small-scale fab of Pixel-Flo's technology can drive revenues in excess of $100 million. And to be clear, success for us is not adoption in a single fab here. We have a much, much bigger opportunity due to the nature of the display industry. The display industry itself is unlocked by manufacturing scale. So panel manufacturers are not making single smartwatch displays or TVs, even 65-inch TVs, one at a time. They're making many displays at once on huge sheets of glass. For LCD, these are 3-meter wide sheets of glass. And that's what allows LCD to dominate in terms of manufacturing capacity. Micro-LED, by the end of this year, will be struggling at a fraction of a percent of capacity. But with the right disruptive, scalable manufacturing technology, micro-LED can capture a significant portion of this market when we reach process cost parity with OLED. So what's holding back micro-LED displays? Well, it's a manufacturing challenge, a manufacturing bottleneck of mass transfer. The semiconductor industry supplies the LEDs in densely packed arrays on small format wafers. And those devices, the fraction of the size of human hair, have to be transferred in hundreds of millions onto these huge display panels. This has to be done with micron scale precision, which is painfully slow and expensive. That can't be done at scale yet. So Pixel-Flo's solution to this problem is an entirely new approach to mass transfer. So what we use is continuous flow mass transfer based on industry standard commercial LED wafers. We then strip the devices off the wafer and suspend them in a solution to create a proprietary micro-LED ink. We then use an extension of an industry standard coating platform to deposit this ink across the full width of these panels. And we sweep this ink across the panel, causing self-assembly of these LEDs directly on the panel surface. This gives us a truly scalable manufacturing solution to unlock micro-LED. This allows us to win across the 4 key cost drivers of display manufacturing compared to the competitor stamp and laser-based transfers that are bound by a more serial processing nature. We do this by leveraging those industry standard approaches. So that allows us to reduce complexity and reduce barriers to entry. We also scale up to these very large display panels, but importantly scale down to small LED die sizes, which significantly drives down material costs. So our product will be a coating head and a micro-LED ink. So this gives us both equipment and recurring consumable revenue streams, securing significant value capture from the supply chain. Our customers are the panel manufacturers. So they make, assemble, and sell the display panels that are then used by the OEMs to make the consumer display products that we all use. We've engaged heavily with the display industry so far, in opening channels with 8 of the 10 panel manufacturers on the screen here, and seeing really strong market pull across the full breadth of this supply chain. We've used this to develop a detailed understanding of the required adoption roadmap for our technology here, to take us from technology qualification through to scale production. And this has given us a set of commercially aligned milestones to deliver this. Each one unlocks significant valuation inflection points, but also revenues. Even at an early stage through NRE, revenues from panel manufacturers, unlocking the potential of these 100 million plus revenues from each scaled adoption. To deliver this, we put together a great team with deep academic experience in the semiconductor manufacturing field, myself and Sunil Gatora from the University of Sheffield. We've combined that with deep display industry experience and commercial been there, done that know-how in Simon Jones, which has given us a really unique team perspective, allowing us to develop a truly disruptive, scalable approach to this problem. We're launching our £4.3 million seed round, which is going to allow us to fully execute phase one of this adoption roadmap, which is to unlock the partner evaluation and early adoption, and deliver traction towards phase two of this adoption roadmap through signing JDAs with panel manufacturers unlocking NRE revenues. I'd love to speak to you about this because we're launching today. Thanks.
Fantastic presentation. Thank you, Rick. So let's open up to questions. Do we have any questions in the audience? We've got one online. Would you like to go first, Ambrose?
Yeah. How important is power reduction for your target customers?
So power reductions are very significant. So the 90% less power consumption than LCD is important, but it's only important because the devices that you're powering use a lot of their power for the display. So for a smartphone, that might be up to around 50%. Smart watches, maybe 80% of the power is used in the display module. So you get really significant payback in terms of battery life there. We've had really interesting conversations with head of display at Intel, who really bought into the idea because it overlaps with their internal technology roadmap, our proof of concept so far. So it's a very significant driver. It's not the only advantage. There's also brightness, and I can't help myself, but the difference between those two screens is brightness, right? That one looks better because it's brighter than that one.
Yeah. Other questions? Got one back there.
I was wondering how comfortable the manufacturers would be with integrating your novel inks, and also how comfortably they would be able to fit your coating heads into their processes, because maybe they're averse to new things.
Yeah, great question. So kind of Pixel-Flo's core hypothesis has always been to reduce those barriers to entry. So all those competitor technologies require significantly more disruption to that supply chain. So we designed this process so it slots in with the tools that the panel manufacturers are already using. So they're already using these coating tool frameworks. So we slot into that. They have these in their fabs already. They're used to it. They're qualified. So the barrier to entry there is quite low. In terms of the inks, ink is an extension. This is a suspension. It's a benign suspension. It's actually significantly easier to deal with than the existing materials market for OLEDs, for example. It's an existing $25 billion market in the display industry. So low barriers to entry there, I think.
Any more questions? Got one more online.
What are the critical technical and commercial milestones over the next 12 months?
So this all comes back to that roadmap that's been developed with in-depth engagement with the display industry. So we spent a lot of time looking at the roadmaps of display panel manufacturers and making sure that we can align those deliverables. So the adoption roadmaps in the display industry tend to be relatively long, but we've got to get in there through evaluation. So we'll deliver evaluation samples to panel manufacturers, then sign these JDAs to initiate development of an R&D tool that will get us into their R&D qualification process. So for the next 12 months, it's about delivering those extrapolatable evaluation samples.
Excellent. Thank you very much. Can I take your mic back? Thank you. So what do we like about Pixel-Flo? Well, OLEDs and LCDs are very power hungry, and they also have limitations. They're expensive to produce, and the ability to be able to produce micro LED displays with up to a 90% power reduction is incredibly useful, powerful. When you talk about watches, when you talk about mobile devices where you're consuming the majority of the power with a display, can have a massive impact. And so there's a huge demand in the industry. The challenge really has been around this placement. So the industry has been looking at this for a while, but they haven't been able to place these accurately and at low cost. And so that's really what's been the blocking here. And so customers have been asking for this for a while. So the ability to be able to show that this works is going to unlock that market. And I think this business model of not only the hardware, but also the ink or the solvent is a really interesting model, because it allows you to be able to get an ongoing value from your technology, as opposed to if you were just selling the hardware. So we think that this has got the potential to unlock a huge market. And we saw the progress from LCDs to OLED and that massive transition, partially because of the power reduction, also because of better performance. But micro LEDs really can be that next generation of display, and we feel that Pixel-Flo can unlock that. So fantastic, exciting opportunity, and that, unfortunately,